A quadratic polynomial with real coefficients and leading coefficient 1 is called disrespectful if the equation p of x is 0 is satisfied by exactly 3 real numbers. Among all the disrespectful quadratic polynomials, there's a unique such polynomial, p of x, right, the special p, for which the sum of the roots is maximized. Find p of 1 for this special p, all right? So if you look at the equation p of x is 0, we can kind of think of it as p of something, right? Where that something is just p of x. So we consider this, it says p of x is 0, and can look at it like this, where whatever's inside here, which is p of x, has to be a root of p, right? Because plugging in p of x into p will give 0. So for now, we'll just say p has roots a, b, where a and b are complex numbers. They can be the same, but we'll see how that goes later. So now that we have the p has roots of a and b, that means p of x has to equal a or b, right? In order for p of x to be 0. All right, so that's our main claim here. Also, if p has roots a and b, we can find exactly what p is, because we also know the leading coefficient is 1. So let's work that through. So we know that by root finding, p of x would just be x minus a times x minus b. No leading coefficient here, so this is just 1. So this becomes x squared minus a plus b times x plus ab. Perfect. And we want this to be a and b. Each of these will be a quadratic formula equation, and each will yield their own 2 complex roots. Note that if a equals b, then we only effectively have one equation with 2 distinct roots, but we need 3 real numbers, right? Or at most 2 distinct roots. Since we need 3, a cannot equal b, all right? So we're going to say a and b then are 2 different right, numbers, all right? So at this point, we know that you have x squared minus a plus b times x plus, and then there's ab minus a is 0. That's one of the equations. And then a plus b times x plus ab minus b is 0 for the other equation, okay? And we need to solve each of these, and we should get a total of 3 real numbers here, all right? And now that we have this, we have a nice way of doing this. If something is satisfied by 3 real numbers, right, then we know that in that case, then one of these, right, because these can't share a root. If these share a root, that means p of x is a, and p of x is, like, for some root x, p of x will be a and b at the same time, right? Because if it satisfies both. And that's not possible. So all the roots of each equation have to be different within each group, right? Or as in, like, if it's a root of this group, then it can't be a root of this group. And as a result, the roots of both groups are basically disjoint. Since we want exactly 3 real numbers, that means one of them will have 2 solutions and one of them will have 1 solution, because neither of them can have more than 2 solutions. All right. How do we have a quadratic, right? That is that has this here with a real, just one real root here. Well, if something has one root, that means it has a double root, right? If it's a quadratic. So in fact, we know exactly what the roots are. So for something to have one root, then the discriminant of this quadratic is 0. So if we plug in, right, this coefficient squared minus 4 times first coefficient times last coefficient, this equals 0. So we can write this as a squared plus 2ab plus b squared equals 4ab minus 4b, right? And now this simplifies to a squared minus 2ab plus b squared equals negative 4b. Take the square root of both sides, and we'll continue on the next page. A minus b equals plus or minus 2 root b all times I, because, or sorry, 2 root negative b. All right. Better to write it like this. All right. And we know that a and b, of course, are our roots. So if we see this, and we know that these roots are, in fact, there's one root here, then this must be true. All right. And now we just see that we have an equation as a equals b plus or minus 2 roots negative b. And we would be done here if we just knew which one it was, plus or minus. So let's figure that out by looking at the second equation. We know that if this has 2 real roots, then we have that a plus b squared, so same thing, discriminant minus 4 times 1 times ab minus a is greater than 0, all right? And since this is equal to 0, you can kind of look at how these differ, right? We see that a squared plus 2ab plus b squared minus 4ab is greater than 4a, or negative 4a. That's one way of writing this equation. And we know this is negative 4b, so negative 4b is greater than negative 4a, which also means that b is less than a when we divide by negative 4, right? Switch the inequality sign. Since a is greater than b, and both a and b have to give us real numbers now, right? We know that a is greater than b, so at this point, since this is non-negative, at this point we do know that we can write a, right, equals b plus, right, 2 root minus b to get that a greater than b. Now all it is to calculate the maximum value of this, maximizing the sum of the roots, which are a and b, right? So a plus b, we can write all in terms of b as 2b plus 2 root negative b. And we just need to maximize that, all right? One way to do that is, first of all, let's just say u equals square root of negative b. So u squared equals negative b, all right? So 2b equals negative 2u squared. So this becomes, right, negative 2u squared plus, right, 2 times the square root of negative u, which is 2u. All right, and to maximize this, we'll just write this as negative 2 times u squared minus u. When is this maximized? Well, this becomes u minus 1/2 squared, right, completing a square, all minus 1/4. You can see that this is maximized when u equals 1/2. All right, and this gives, in fact, the sum of the roots being negative 1/4. Now, since u is 1/2, then b is negative u squared, right? So b equals negative 1/4. And then to take a look at a is negative 1/4 plus 2 times square root of 1/4. So 2 root 1/4 is 1, so a is 3/4. Okay. Actually, the a plus b minimum is actually, or sorry, maximized is at 3/4, negative 1/4, which gives us a sum of 1/2. But our question asks, what is p of 1, right? So we rewrite it as x plus 1/4 times x minus 3/4, which is x squared minus 1/2 x minus 3/16. Now you plug in 1 is 1 minus 1/2 minus 3/16. Right, subtract everything, it becomes 5/16. That's our final answer, and that's A.